Hi everyone, and welcome to the third of 4 videos on past exam questions on lattice enthalpy. And again, we're looking at a question where we've got a table of different enthalpy changes and they've given us all the values. So all of these questions seem to start off exactly the same way, so they're very recognizable. There's actually nothing to do, there's just a whole page with information. So everything else is on the following page. What we've got to do here is another one of these matching up the right enthalpy changes to the diagram. Okay. So what's going on? This is the most obvious one here, this big negative one. We've got gaseous ions here and we've got a solid. This is the lattice enthalpy. So which letter is that? The lattice enthalpy is G here. So that should be that one. Right, and then let's work our way through the rest of these. This is the other process that you can use to make magnesium chloride, but this is from solid magnesium and chlorine gas. So these are the elements in their standard states. So this therefore must be the enthalpy change of formation. So that is going to be D, enthalpy of formation. That's going to be that one. Here we've got atomization of magnesium, because we're going from a solid to a gas. So atomization of magnesium is E. Here we've got atomization of chlorine, because we're going from 1 mole of chlorine molecules to 2 moles of chlorine atoms. So that's atomization of chlorine, and for some reason we don't need to put a letter on that one. Okay, fine. Here we've got magnesium as a gas going to Mg+. So this is the first ionization energy, and then this is the second ionization energy of magnesium. So first ionization energy is B, and then the second ionization energy is F. For some reason, they're in a very strange order there. But B and then F. That should be B, and that should be F. Okay. Right, then we need to calculate it. So again, we're going to do the same method that we've done before. I'm just going to copy the numbers across. So A is minus 349. That's not on here. That's the electron affinity of chlorine. So that's this one. But here we've got 2 chlorines. So this is going to have to be times by 2. And the atomization of chlorine is the other one. So that's here. So the atomization of chlorine is plus 150. That's the other one that's going to have to be times by 2. Lattice enthalpy is the one we want to work out. So the 2 ionization energies are plus 736 and plus 1450. And then we've got atomization of magnesium, which is plus 76. And then finally the enthalpy of formation of magnesium chloride, which is minus 642. Okay, right, then we're going to say we're trying to calculate this one. So we're starting here and we're finishing here. So therefore we're going to have to go the other way around. So we're going to have to go up there from the start and then all the way down this side. So then let's just write these numbers out. What have we got? We've got minus 349 times 2. We've got plus 1450. We've got plus 736. We've got plus 150 times 2. We've got plus 76. And we've got minus 642. Right, and then what are we doing? Our arrow is in the opposite direction to the arrow that's already there. So that one's going to have to be a negative. These 2 arrows here are opposites, so the 1450 is going to have to be minus. B here, these arrows are opposites. Opposites again. Opposites again. And then finally these 2 arrows are in the same direction, so we're going to add on that last one. So now we need to calculate this. So we're doing minus 349, so that's just 349 times 2. So you can see what I'm doing here. Then we've got minus 1450. We want to then minus 736. We want to then do minus 150 twice. We want to do minus 76. And then we're going to do plus minus 642. So that's minus 642. And we get minus 2506, which again is a big negative number, which suggests we've done it right. It should be a very negative answer. Right, and then we have the last bit on this question. Magnesium chloride has stronger ionic bonds than sodium chloride. So what's going on here? If we've got stronger ionic bonds, it must be because there's a stronger attraction between the ions. Why is there going to be a stronger attraction between the ions? Well, the chloride ion is exactly the same. So it must be the sodium versus the magnesium. And remember, the two factors that we're looking for are the ionic charge and the ionic radius. So we can say that magnesium ions have a higher charge because they're Mg2+ than sodium ions. And the other thing is the radius. And we saw this question in the previous video, that again, it's the same one. It's magnesium against sodium again. Okay, they're quite repetitive with the questions. It has a higher charge and it also has a smaller radius. Remember, as you go across a period, the radius does decrease slightly. So there's a higher charge in sodium ions and a smaller ionic radius. Do say ionic radius, not atomic radius, because we are talking about ions here. So it has a higher charge density and attracts chloride ions more strongly. Okay.